I'm at the world's largest machine which straddles Switzerland and France, the Large Hadron Collider at CERN, and a facility where India has had a big role. I have with me Dr. Tapan Nayak, associated long time with the Department of Atomic Energy and a scientist at CERN. Namaskar.
Namaste. Namaste.
Uh,
Namaste.
Dr. Nayak, what are we seeing here and what is India's role in this large pipe-like machine?
Yeah, okay. So before I come to this one, can I give you a little bit background
Sure.
of how India
Sure.
came to CERN?
Sure.
So India came to CERN. In fact, Indian scientists have been at CERN since 1960s. We go back long way coming to CERN. Some theorists, those who theory calculations and all that, they have been associated for a very, very long time. Then we started organizing ourselves how to get into large scale experiments. The large scale experiments, they require large collaborations. It cannot be done by 10, 15 persons. It is done by thousands of persons. So Indian scientists wanted to be a part of this big endeavor at CERN. So what they did is that they organized themselves at the Tata Institute of Fundamental Research with the Delhi University, Chandigarh. They organized themselves. They came to the L3 experiment. Then after that time, the Variable Energy Cyclotron Center, Calcutta, where I come from, that is the Department of Atomic Energy unit. So we started working on something called a quark-gluon plasma. In experiments we did in SPS, another facility, not LHC. LHC concept came in 1990, Large Hadron Collider. 1992, 93, it got approval. Indian scientists have been thinking we should be part of the Large Hadron Collider. In fact, from the beginning, our engineers and scientists, they got into, okay, we should be a part of this big endeavor of 27-kilometer Large Hadron Collider. Not only that, not a part, we should be a big part, making things in India and bringing it here. So that whole effort started with DAE. Then DST, because many of our universities and institutes, they wanted to be also a part. So DAE, DST secretaries that time, they got together. They came up with brilliant idea that India can be a big part of making accelerator for CERN, through which we learn in India. Many things we learn in India. So what we did is around 92, 95, 96, we organized ourselves in a nice way. We got a part of this big accelerator of Large Hadron Collider. It's called large because it is 27 kilometer circumference.
27 kilometers.
27 kilometers.
Underground, 100 meters below the ground.
Yeah, it's between 50 and 150 meters underground. It's below the mountains. We went to the mountains, below the mountains, in fact, and almost close to the airport, like Geneva.
And it's straddled between France and Switzerland.
France and Switzerland. The 27 kilometer, 2/3 is in France, 1/3 is in Switzerland, and it's one of the marvels. So India, coming to Indian scientists, so RRCAT in Indore, BIRC in Bombay, some of the physicists from my own center, Calcutta, BECC, so they started, we can make the magnet. These are what happens when you accelerate particles. You are accelerating protons or ions. These are charged particles, positively charged particle, proton, ions also. So let's say you take a lead ion. You strip out the electron, it becomes an ion, it's a positive. So you need to give a kick so the particle moves at a speed, right? You give kicks through electric field, then you have the magnets to guide the particles in the proper place. So we need huge amount of energy. The physics purpose, we will go afterwards. The physics required that we need many, very, very high energy. These particles moving at the speed of light.
So what were the parts which India supplied?
So now these magnets, these are big, large superconducting magnets. The inside is superconducting. Half of the magnets were made in Bharat Heavy Electrical Limited, BEL, in India, under the supervision of RRCAT Indore and BIRC. And at the same time, that is the main thing, magnet. Making the magnet and also testing. At some point of time between 95 and 2008, 2010, there would be 100 scientists from RRCAT and
Bhabha Atomic Research
Center and Calcutta coming over here just for testing.
Sure.
Just for testing. It really was the bright
It's like
time.
a mini India in CERN.
They would be cooking in the cafeteria. They would be talking in Hindi and in all our Indian languages. It's really
And we
fantastic
also
time.
made the
And
things which support this
then-
magnet.
Then the main thing is that if you see 27 kilometers, there is a company in Bangalore called Abhasarala. I have been there. They showcase this one. You see this small tiny thing. This is a red color. We don't see, may not see the red right now. This is the pedestal. So this pedestal on which these magnets, the 27 kilometers, they stay. So these are all made in Bangalore. This company.
They are hydraulic.
They're hydraulic. They're controlled. They're smart. They're
Yeah. And
smart in that sense.
also let's come to the scientific contribution. How many Indian scientists came and when did we become an associate member?
Yes.
How much have we invested?
Yeah, okay, coming. I'll come slowly to that. So this is the Large Hadron Collider. So when the Large Hadron Collider came, it's the collider, but then this is done by engineers. We have mechanical, civil, electronics engineers, computer engineers who made these things. Then we have to do experiments. Scientists who come and do experiments to get the physics point of view. We got into two large-scale experiments. One is called ALICE experiment, a Large Ion Collider experiment, and another is called CMS experiment, Compact Muon Spectrometer. These two experiments out of four main experiments, we got into two out of that. And right now we have like about 130, 140 scientists in CMS, 130, 140 in ALICE. We are about 15 to 18 institutes from India participating in CMS, another 15, 18 participating from ALICE.
And how
So in
many
total,
countries are there who are participating in the CERN experiment?
the CERN experiment, we say that more than 100 countries
Wonderful.
participate.
And India is a big player.
India is a big player. In both in ALICE and CMS, India is a bigger player. In ALICE, we are about 5 to 6% of the whole ALICE contributors, and in CMS is about 3-4%. CMS is bigger, number is much bigger.
See, one big achievement which happened from the Large Hadron Collider was the discovery
Yes.
of the Higgs
Right.
boson.
Right.
And let's call this boson with a big B.
Yeah.
Because it came after Bose-Saab.
Right.
Now, what was that discovery of the Higgs boson or the God particle?
So the Higgs boson, okay, the whole thing of our study at CERN is looking for the basically fundamental science, fundamental nature of the particles, fundamental interactions. So we have 4 different interaction forces, we have structure of the matter and everything. So this matter, when it takes mass, the mass comes through Higgs boson. I'm not an expert on that.
No,
that field.
you understand enough, sir.
Yeah, not an expert. This is the name, the Higgs. In fact,
From Peter Higgs.
Peter Higgs, and he got the Nobel Prize after the discovery at CERN. The experimental discovery, he got the Nobel Prize the year after. In fact, the boson is half of the particles are bosons, and another half is fermions. So they are particular type of particles. So Higgs
And bosons are named after whom?
Okay, Bose, our own Bose from Calcutta. In fact, yeah.
So people should know.
S.N.
The
Bose.
Higgs boson, the boson comes from the name of legendary Indian scientist S.N. Bose.
Yeah.
And now it's no longer Higgs with a capital H and boson with a small b. It is Higgs with a capital H and boson with a capital B. India asked for that, it happened.
Indian scientists, in fact, from the CMS experiment, I must give a lot of credit. There are a lot of students, there are a lot of researchers who participate in the data analysis. So they were a part of the discovery of the Higgs boson, in fact. So in my case, we are looking for quark-gluon plasma, which in fact stayed within a microsecond of the Big Bang. So it's a three quarks and gluons, and it's called a quark-gluon plasma. The discovery was 50 years back. We are just combining all the knowledge we got in last 50 years in a book.
And the Department of Atomic Energy also gave to CERN that beautiful cosmic dance of the universe being done by Lord Shiva, the Nataraja statue. Tell me a little bit about that.
Yes, it was mostly brainchild of Chidambaram Saab and Vikas Sinha, who was Chidambaram Saab was the chairman, Vikas Sinha was the director of Calcutta VECC. So both of them thought about it in 2004?
Yes, around that time.
Around that time. So it's a beautiful statue, and we'll show the statue in some pictures. And the statue has been doing, it is really big structure, and it occupies 2 main very important buildings of CERN.
What does the statue signify What does the cosmic dance
this
of Lord Shiva signify? And why have we placed it at CERN?
In a simple form, the cosmic dance or the Shiva concept signifies destruction. Destruction happens. When does destruction happen? You may be knowing this better. So destruction, in our case, what we do, we don't create energy. We destroy things. We collide proton on proton at the speed of light, or lead on lead at the speed of light. Two big trucks coming at the speed of light and they collide, speed of light. And you have fragments coming all over the place. We analyze the fragments to discover God particle. We analyze the fragment to discover quark-gluon plasma. So that destruction which comes through that, so that is one of the things motivated people. Let's do the cosmic dance Shiva statue here. Nobody objected during that time. Nobody has any objection till now, and it occupies one of the most premier place in at CERN. Right now, what happens?
It doesn't matter. We have the cosmic, that Nataraja statue is going to be placed back at the
we are
correct
refurbishing right now, so it will be ready within 2 weeks. That's what I was told.
Lovely.
The pedestal is ready. The statue is coming back. In fact, CERN has taken interest to do the remodeling and all that. So they'll
So when we understand the universe, we, in a way, in our old scriptures, the Nataraja dance, the cosmic dance of Shiva, there is an understanding of the making and the breaking of the universe. Correct, sir?
Yeah, exactly. I think there are people, Carl Sagan and all there are many in India, so who have taken us back in Upanishads and all our Veda, trying to make this connection to what we discover right now. In fact, these finest particles which you see, quarks and atoms, there are some mentions, and I'm not very qualified to go into that, but I think there are, maybe I should take up this one to write a book about this.
Sure.
It's really
now
fantastic.
let's come to the future.
Yeah.
See, the Large Hadron Collider is being upgraded.
Yeah.
The luminosity is being increased.
Yes.
What are you going to search now?
Yeah. So the Higgs particle for the Atlas and CMS, these two big experiments, CMS in which we participate, we are looking for completely new physics. We have a standard model of what we understand, all these three big forces. Other than the gravity, we have the electromagnetic weak force and the strong force. We try to understand that in a standard model. The standard model, we want to go beyond standard model, increase the energy to see whether the standard model still holds. And there are many search going on beyond standard model. There is a search going on the dark matter search. There are and the Higgs also.
Is the Large Hadron Collider, where India is a big player, now going to be looking for that elusive dark matter, 95% plus of the universe which is not seen? Is that correct?
That's one of the main goals. Another goal, there are many goals. And the Higgs also, in 2012 we only saw few, or tens or hundreds. So now they are producing like in thousands. So they want to use the Higgs as a probe to understand the.
So is India participating also in the search for the dark matter at CERN?
Indian scientists are doing the analysis, and of course India is participating in the accelerator, in the experiment, in the upgrades. We are upgrading the CMS experiment, upgrading the ALICE experiment. We want to understand that also. For what we are doing, we have in the quarks, we have six quarks. Some are very light quarks. Proton, neutron, they conserve up and down, light quarks. They're heavy quarks, which are much heavier. We are using the heavy quarks as a probe to understand what is going on in the beginning, early part of the Big Bang. How this matter moves in the high density, high temperature. We create temperature 200,000 times more than the core of the sun. This is the highest ever temperature ever measured in the laboratory, 200,000 times. That temperature existed in the beginning of the universe. We go back. Now we are using these quarks as a probe. What is this matter made up of? What is the flow? What is the viscosity? All the thermodynamic properties we are trying to understand.
So India trying to understand what happened 13.8 billion years ago when the universe started with the Big Bang. Is that correct?
Time t equal to 0. That's a better way to say. Time t equal to 0. We didn't exist. I am only, some tens of years old. But this one was 13.8 billion.
13.8 billion years.
13.8 billion within 1% error bar. In fact, it's very well known because of there's something called a cosmic microwave background radiation that
is what we are trying to understand.
We are trying to understand what happened at time t equal to 0. And we cannot go back in time. Before time t equal to 0, we don't know what happened. Something happened time t equal to 0. Everything started from a very, very small point with very high temperature, high density matter and expanded very quickly. This expansion we are trying to understand. Now, these big telescopes which are going to sky, you have the Hubble telescope, you have the James Webb, they can go back to cosmic microwave, which is 380,000 years after Big Bang. But there are some probes which are also trying to go below that. But we can go back to time t equal to 0, which nobody can do.
What a
Nobody
pleasure.
else can do.
Thanks a lot for
Thank you
speaking
so
to
much.
me, Dr.
Thank
Tapan
you.
Naik.
Thank you. Thank you.
So,
it's a pleasure.
at the Large Hadron Collider at CERN, on the border of France and Switzerland, after all, both Dr. Tapan and myself, Palla, we are actually star dust, all created because of the death of certain stars at some point or the other. So, India, along with hundreds of scientists from hundreds of countries, all working to decipher what happened at the beginning of the universe. And India, a highly respected member in the community of the Large Hadron Collider. In CERN, in France and Switzerland, Pallav Bagla for NDTV.